Alright, so let's talk about arrays. Most people are familiar with this, but they don't actually know how they work on deeper level, and that's something that you really need to understand, especially going into computer science background when you're gonna be picking different structures on how you can run something very quickly. So arrays, let's talk about arrays. Well, the first thing that most people notice when they look at arrays are the fact that they have a fixed size. Now, typically, this is seen as massive disadvantage and inconvenience, but there's a reason they have that, and we're gonna talk about that in a second. But essentially, this fixed size means that when you create an array, you need to pick. Before even starting the problem or using the array, how big your array is gonna be. Now, if you don't know this answer and you don't know how big it's gonna be, how do you decide? Well, that's typically when you might use a different structure. But anyways, that's something to note that you have to pick how big it's gonna be before you even create the array. Now, the next thing with this fixed size is that if so you create an array that's size 10, and you now want to add an 11th item to it. Well, you can't do that because there's no more room in the array, so it can be filled up. And another thing with this fixed size is that say you create an array and maybe you're like, you know what, I don't know how big I want this array to be, but I'm gonna make it size 10,000. So that's just massive enough that I don't want to worry about it. Well, if you do that, that's another really big disadvantage because what you've actually essentially done here is if you put a little slot of memory here, just, I'm just drawing like a mock computer memory, and you've said I'm gonna make sure that I have 10,000 spaces for items in my computer memory here, which means that you're actually locking up a ton of memory, and this is known as memory leak. By creating such a massive array that you're not actually gonna use. So when you only have a few items in a really large array, that again is another disadvantage of an array because now you're using all of this space in memory that could have been used for something else. Now in modern day computing with people having 60 and 32 gigabytes of RAM in their machines, that's not really a huge issue but still something to think about when using an array. Alright, we've talked about a few disadvantages of it. What's one of the advantages of an array? Array will one of the advantages of it is the fact that you can index items. Now a lot of people take this for granted, but we know that we're using an array. We can use something called indexes. Indexes. That's the spelling of index. And we can look up any item in our array by simply knowing where it is. And that position is being held in our computer memory because of this big size. Now, when we look up on an item, this actually happens in what's known as constant time, which is very fast as you can do something in computing. So because we have this big size in our memory, let's say we have an array of size 5. Array of size 5. So 1, 2, 3, 4, 5. 5 squares. These are the 5 squares. Maybe these are items here. 7, 9, 10, 11, and 12. like that. You know, you know that the indexes go from 0 all the way up to 4, like that. These are the indexes 0, 1, 2, 3, 4. And if I want to look up any item, all I have to do is to know is where it is. So like index 3, and I can grab that immediately, as opposed to using something like a list that takes a lot longer to do that. That's something to remember, that indexing items is getting any random item takes O1 constant time. Now, what about inserting, deleting, and removing items? Well, let's look at how that works, because it's not quite as fast. Now, because of this big size in our memory, if we want to insert an item, this is actually quite computationally heavy. Let's say we have this array and we want to insert, I don't know, like an item. Five in between 7 and 9. This. Well, to do this, we actually need to shift every single item in our array past this point. Past this point. Over. And we might even have to remove the last element to make room for this new inserted array. So when we do that, it looks something like this. We have the box 7, which is index 0. We now squish in our new index 5. So this is the index 0 and 1. And now all of these indexes need to be incremented by 1 and shifted over. So 9 needs to go where 10 is, 10 needs to go where 11 is, and 11 needs to go where 12 is, and 12 is well lost in emptiness. It's gone forever. Right, and that's what happens when we insert an item at least into a full array. So that takes what's known as O and time. It's gonna continually take longer and longer to insert an item, especially in the beginning of our list. So once we insert that item, we have 9, we have 10, and we have 11. And these are moved to new indexes, so to 2, 3, 4. Now let's look at the example of removing an item, and this is the exact same problem we've run into before. So let's say we want to remove item 10. We want to remove item 10. We want to just get rid of it. Well, to do that, we now need to shift all the items after the item 10 down by 1. So we can rewrite this entire array, but we need to now switch forward to be index 3 and replace the value of item 10. So now we have an array that ends up looking like this. 7, 5, 9, 11, and an empty box. 7, 5, 9, 11, and then an empty square that has no value in it. And what we've done here, we've set 0, 1, 2, 3. This is still index 4, but now we could call that this null because we've just removed that last item from 11. Null. That's called null, the empty square or empty box. So that is what happens when you're inserting and removing items. So quick recap here of everything I've kind of covered. Arrays have a fixed size. You need to decide how big you want your array to be before you start even creating and working on the problem. If you make your array too big, then you're gonna have a ton of room in memory that's just being wasted, and that's a memory leak. If you need to insert remove items, that's gonna take you O and time. This is O and time, which is a long time for at least the structure to remove and add items. And the only really advantage of using an array, and when you should use it is if you're looking to randomly access items, because that happens in O1 time. Where is the O1 time? This is the O1 time, which is faster than almost any other time that we can find. Now, arrays do have their use, especially if you're just looking for, like a small quick thing to implement. But you should definitely considering using something like a linked list or a double linked list if you're gonna be removing an item, adding items from the front and back of the array quite often. Even just inserting randomly is gonna be faster in some of those structures because of the way that they're set up. So just something to consider. I hope you guys know how quickly arrays are on and kind of how they work in the computer's memory. It's definitely an important thing to understand. So if you guys learned something, please make sure you hit a like and subscribe to the channel. And with that being said, thank you. This is the example.